discuss about climate change. So my name is Dr. Mothi Paul. I'm a professor of chemistry in the PSN College of Engineering and Technology, TIRUNELVELI. So today we will go through it in a step-by-step manner. See, climate change is a very, very important term in today's world. Why it is so? See, today we are seeing rising sea levels, frequent floods, summers are getting hotter and hotter, and cyclones and hurricanes are occurring very frequently. See, these kind of pictures you might have seen every year. Okay. So what is climate change? And to understand what is climate change, we need to know certain things. Okay. So before that, we will just go through it. Climate refers to the long-term patterns of temperature, humidity, wind, precipitation, and other atmospheric conditions in a particular region. Okay. So you have seen that long-term patterns of temperature, long-term patterns of humidity, long-term patterns of wind, precipitation, and other atmospheric conditions. So it talks about a long-term pattern, not any short-term pattern. Okay. So that is the climate. Climate is always a long-term pattern. And now we see what are the factors that are affecting climate. Okay. So climate is affected by many factors: latitude, altitude, distance from water bodies, ocean currents, wind and air mass, topography, solar radiation, human activities, volcanic activity, atmospheric pressure systems. So these are all the factors that affect climate. So I told you that climate is a long-term change. Okay. So depending upon the distance from water body, ocean current, wind and air mass, topography, that is land form, how it is it a mountain or is it a plain area, solar radiation, human activity. Okay. So why we are discussing human activity here? See, human activity, it involves the vehicles, industries, or burning, thermal power plants. All the human activities, they have a big impact on the surroundings. Okay. And then volcanic activity, that is a very, very important thing. If there are any volcanoes actively present anywhere, they can have a tremendous effect on the climate. And then the atmospheric pressure systems. Okay, what happens when every year we get rainfall in a particular period? Okay, that is called monsoon in our region. So that is happening due to changes in pressure and temperature in the atmosphere. That is the atmospheric pressure system. Okay, so these are all the factors that affect climate. Now we will see how Earth behaves. The overall, the Earth is a natural greenhouse. Why do we call it as a natural greenhouse? All of us may be aware that there is something called a greenhouse. Okay, a greenhouse is a place where plants are raised. Okay, it's present in some biological experimental places where they grow plants inside a greenhouse. The main purpose of having greenhouse is to have a little higher temperature inside. Okay, greenhouse is made up of glass. It's actually a glass house. But since there are plants inside, sunlight can go inside the greenhouse and the plants take up the light. Plants produce a lot of water vapor, okay, because of transpiration. So inside the greenhouse, temperature will be very hot as well as it will be very, very humid. So now you see, now look at the Earth. On the whole, it also resembles a greenhouse. How is it? See, Earth has an envelope of atmosphere. Atmosphere means gases around it. Okay. Though we don't have any glass to cover it, the environment itself, the atmosphere itself acts as a cover. Okay. You might have seen that. See, this is Earth. This part is the atmosphere. Okay. So solar radiation can enter. Inside the atmosphere, what we have a lot of gases. So the greenhouse gases trap the heat and then they radiate it. That's how we can keep our earth warm. So it helps maintain temperatures suitable for life. Without it, earth's average temperature would be around 18 degrees instead of 15 degrees. See how the temperature changes. Okay. Now, what happens when we have lot of gases that are called greenhouse gases? What do they do in nature, in atmosphere? What is their role? So before going to that, we must understand what are the different gases that are present. So all of you know, our atmosphere, we have a lot of water vapor. Okay, we call it as humidity. We feel hot, we feel very humid in summers. Okay, that is due to water vapor. And then carbon dioxide, that is CO2, it is released by our respiration or our human activity, cars, vehicles, the industries, they all release carbon dioxide gas. Methane gas, it is produced by natural wetlands and they are also produced by animals. For example, cows, they produce methane due to their digestion. And sometimes decomposition of organic material also causes methane production. So methane is CH4. Then comes nitrous oxide, that is N2O. So it is emitted from soil bacteria and ocean processes. Okay, so that is nitrous oxide. Then we have ozone, O3. All of you know oxygen, that is O2. But here there are 3 atoms of oxygen joined together. It is called O3, that is ozone. Ozone absorbs UV radiation and contributes to the greenhouse gas effect. Right? Now, next we will see what happens when carbon dioxide increases in atmosphere. Carbon dioxide is a key greenhouse gas. We all know that. Okay? When carbon dioxide level increases, the temperature, global temperature also increases. Okay? Natural sources of carbon dioxide is respiration, volcanic eruption, ocean release. Ocean also releases carbon dioxide. Human activities have significantly increased CO2 levels since the Industrial Revolution. So this graph shows how carbon dioxide levels are increasing. See, before 1900s, the carbon dioxide level was almost steady. But after 1900, 1930, 1960, 1980 or 90 maybe, or 2020, see, it is going exponentially high, right? Okay. So with these things in mind, we will go about one by one. What are the different gases? First we have seen carbon dioxide. Okay, carbon dioxide. Now we are going to see methane gas. See, this picture shows methane gas. Methane is a molecule containing 1 carbon and 4 hydrogens. Okay, CH4. And an interesting thing about methane is it is 25 times more potent than carbon dioxide. In doing what? In trapping heat over 100 years. Okay, so who traps more heat, carbon dioxide or methane? Carbon dioxide traps heat, but methane traps 25 times more heat. Okay, so that's a very important fact. What are the sources of methane gas? I told you already, it is livestock digestion. Okay, for example, cattle digest food. It's also called enteric fermentation. As a byproduct, lot of methane gas is released. And then there are rice paddies wetlands, they release carbon dioxide gas, landfills and sewage treatment. So this is where human beings come into picture. Okay, landfills and sewage treatment, and natural gas leaks and coal mining. Alright, so these are all different sources of methane gas. Okay, so what happens if methane gas gets more? You will have more heat in the atmosphere. Right, so next greenhouse gas is called nitrous oxide. Nitrous oxide, you can see the molecular structure here. It is having two nitrogen atoms that are connected together and one oxygen atom. So it is N2O. So this nitrous oxide, you will be surprised to know it is 300 times more potent than carbon dioxide. In doing what? In trapping heat. You see here, previously we have seen methane that is 25 times more potent in trapping heat, but nitrous oxide is 300 times more potent. Where do we get this nitrous oxide from? So nitrous oxide, it comes from agricultural activities mainly. Okay, that means what? We are adding fertilizers to our fields. We are just adding, keep on adding fertilizers. Okay, so these fertilizers, they produce nitrous oxide. Soil bacteria, ocean processes, they also contribute to nitrous oxide production. So soil bacteria, as a byproduct of their fermentation, they also produce nitrous oxide. And then a more important thing is burning fossil fuels and biomass. Fossil fuels, all of you know, fossil fuels are nothing but the petrol, diesel, kerosene, whatever we use for our transportation and for other activities. And biomass, that is nothing but wood. Okay, in different villages, people are using wood to cook. Okay, so the burning of biomass, burning of fossil fuels, they release some amount of nitrous oxide gas into the atmosphere. What happens after it is released? This nitrous oxide gas stays in the atmosphere for over 100 years. Okay, so suppose you release some 1 kilogram of nitrous oxide today, so it will be in the atmosphere for 100 years. So that is the most important thing. Then comes water vapor. So water vapor, water all of us know. The formula for water is H2O. Okay, H2O, and H2O, the molecular structure is called a bent structure. Okay, so oxygen in the middle, on both sides we have one hydrogen on left, one hydrogen on right. Okay, so it's a three-dimensional view, we can rotate and see. So it's a bent structure. H2O molecule is the most abundant natural greenhouse gas, right? So we know it is raining. We have rainfall, we have water bodies, we have seas, oceans, everything contains water. And what happens when water is heated? It becomes water vapor. Most abundant natural greenhouse gas, it increases with rising temperature. Now, what is this? It's called positive feedback loop. What is that positive feedback loop? It rises with rising temperature. Okay, so it traps heat and contributes to the increase. Okay, so water vapor is very, very important greenhouse gas. But then comes ozone. So ozone I talked about already. So it's 3 oxygen atoms connected together. It is also having a bent shape. Ozone is also called as tropospheric ozone. Tropospheric ozone. So it is found in the lower atmosphere. There is also a ozone that is present in the upper atmosphere. That is called the protective ozone layer. But this ozone is produced because of pollutants, especially vehicle emissions. And it acts as a greenhouse gas by trapping heat. Harmful, very, very harmful to human health, and it is harmful to ecosystem. Ecosystem means the plants and animals, all life form, they are called ecosystem. Okay. So far we have seen different gases, and now we are going to see one type of gas. They are called fluorocarbons. There are two types actually. One is called CFC, another one is called HFC. CFC is nothing but chlorofluorocarbon. Okay, chlorofluorocarbon. CFCs. HFCs, it stands for hydrofluorocarbons. Okay, you can see the picture here. If there are two chlorine atoms and two fluorine atoms around a carbon, just imagine it is like a methane gas. Carbon is in the middle. There are 4 bonds, 4 atoms. 2 are chlorines, 2 are fluorines. It's called a CFC. If there is one is hydrogen, it's called a HFC. Okay. So likewise, there can be number of carbons, there can be number of chlorines, fluorines and hydrogens. So different combinations are there, and everything has a name or number given. So these are all synthetic gases. Where do they come from? They are mainly used in refrigeration and air conditioning, and also aerosols. You might have seen that people are using some air fresheners or some deodorants or perfumes. They may contain aerosols. Okay, they may contain chlorofluorocarbons, hydrofluorocarbons, and these fluorocarbons are released from our air conditioners and refrigerators, and they are extremely potent gases for greenhouse effect. See here, I want to point you out to the number of times it is stronger. So it is 1,000 times stronger than CO2. So this means CFC and HFC are one of the biggest threats for global warming, climate change. CFCs also damage the ozone layer. Okay, so now the CFC, they are all regulated by something called Montreal Protocol. Montreal is in Canada, and this protocol limits the use of CFCs in our refrigerators and air conditioners. HFCs are being phased out. That means they are being removed, they are being stopped. Usage is being stopped due to their high global warming potential. Okay. So now we have learned what CFCs and HFCs are and what do they do in our atmosphere. So they are 1,000 times stronger than carbon dioxide. Okay. So now we have seen what are the different contributors, what chemicals act as greenhouse gases. Now we will see what is the effect of greenhouse gas, or rather we will see the emission of greenhouse gas, how they are increasing, they are keep on increasing. Okay, so this graph on the left side and right side, they show year wise how they are increasing, how the greenhouse gases are increasing. Okay, and what is the most common contributor for the greenhouse gas. You see in the pie chart here, carbon dioxide is 65%, other sources from fossil fuels is 65%, from other sources 11%, methane 16%, nitrous oxide 6%, and CFC is 2%. Okay, even though they may be 2%, but we all know now that they are 1,000 times more potent than CO2. Okay, so as I told you, we are going to see the effects. The first effect, ozone layer depletion. See in the picture, you see the earth is mapped, it's a thermal map of Earth in 1984, that is on the left side, and 1997 on the right side. See the blue things means there is more of low ozone, the red or yellow means high ozone. So 1984 you see the red regions and yellow regions are there on the polar regions. That means there was more ozone at that time. Just in 10 years or so, there are less ozone layer. So you can see the blue region is expanding and expanding. Okay, so the green region is also ozone. But blue region means very low ozone. Okay. So ozone layer is a protective layer in the stratosphere that absorbs harmful UV radiation. Ozone molecules prevent excessive ultraviolet rays from reaching the earth. Depletion of ozone layer increases UV exposure. So what happens if we have more UV exposure? UV rays can harm our skin. They can damage our skin. They can cause cancer, skin cancer. Over the long term, they can have very dangerous, life-threatening effects. But who protects us from the ozone, from the UV light? That is ozone layer. Okay. So the ozone layer depletion is one of the most important effects of climate change, greenhouse gases. Right. So what happens when ozone layer is depleted? I told you already, skin ailments. Okay. Then disturbed plant life cycles. Then marine life, destruction of marine life. So these are all the effects, common effects. So it increases UV radiation, more harmful rays are reaching the earth nowadays. High risk of skin cancer, high risk of cataract, weakening of immune system. What are the environmental effects? Plant growth are affected, crop yields are affected, marine ecosystem is affected. So overall, it affects the climate as atmospheric temperatures and weather patterns are changing so much. Okay. So next we will see global warming. In the beginning, I told you briefly about global warming. Global warming simply means that the earth is becoming warm. Okay. It refers to the long-term increase in Earth's average temperature. It is primarily, the global warming is primarily caused by human activities that increase greenhouse gas emissions. And global warming leads to significant environmental and climatic changes worldwide. Okay. I told you the different factors for causing global warming: vehicular emissions, the aerosols, the CFCs from canisters, burning of biomass, power plants. Okay, all human activities. They are all natural activities. They are all human activities. Okay, all human activities, they cause increase in CO2, increase in methane, increase in CFCs, and they are all trapping more heat. See, this picture clearly shows heat is entering from sun into the Earth's atmosphere. Now, this heat is also absorbed by greenhouse gases, CFCs, CO2, methane, nitrous oxide, etc. And what they do instead, at the night time, they radiate the heat. So how the temperature of the earth will increase, and this concept is called global warming. So causes of global warming, they are burning of fossil fuels. Fossil fuel means coal, oil, gas, release of CO2 in the atmosphere, deforestation. That means we are cutting a lot of trees. We are removing the forest cover. Less tree means more carbon dioxide, because carbon dioxide is the natural food source for plants. They absorb carbon dioxide to convert it into food. Industrial activities, factors release greenhouse gases like CO2, methane gas, nitrous oxide. Agriculture, livestock farming procedures produces methane, a potent greenhouse gas. Waste and landfills, decomposing waste generates methane emissions. Okay. So I told you before, effects of global warming are far-reaching. See, on an average, Earth's temperature has increased by over 1 degree since the pre-industrial era. So you might think 1 degree can maybe a small number. Even though it is a small number, this causes a lot of effects like melting of ice caps, rising sea levels. What do they do? Causes coastal flooding, loss of habitats, extreme weather events are very frequent these days. Hurricanes, heat waves, droughts, wildfires, and all these things lead to loss of biodiversity. That means many species are at risk due to changing climates. And the impact on human health is also very severe. Heat waves. So now we are experiencing a lot of heat waves in northern India, especially Delhi, northern part of Rajasthan. They experience huge heat waves. Air pollution is there, increased disease outbreaks. So all are related. That is why it is called effects of global warming. Okay. So evidence of global warming: rising carbon dioxide levels. Current levels exceed 420 ppm, which is highest in 800,000 years. You see, glaciers retreat, Arctic ice melts, increased ocean temperature. See what happens when ocean temperature increases? The ocean becomes warmer and they disrupt marine life and weather patterns. And more frequent climate disasters. Records show increasing extreme weather events. So, in this class, we have seen what is climate change, what are the causes, what are the main sources of climate change, and what are the effects of climate change, how it overall affects the life on Earth. That is what we have seen today. I hope you understood all the concepts very clearly. So let me recap quickly in a few words. So climate change is caused by greenhouse gases. Main greenhouse gases are CO2, methane, nitrous oxide, ozone. So these gases are accumulated by human activity, and what happens because of that? Carbon dioxide or greenhouse gas, they trap more heat, and finally they increase the temperature of the earth. When the temperature of the earth increases, weather systems are totally disrupted, life is slowly disrupted. We may not even know. So it is high time that we focus on reducing the effect of climate change by adopting more green and